Hello, my name is Thomas Platt, and this is my Hawk Grow Showcase 2020 presentation on my project on the use of entomopathogenic nematodes to control the obscure mealybug, Pseudococcus viburnii, on pome orchards. Pseudococcus viburnii, the obscure mealybug, is a key pest of South African pome orchards. These are small-scale insects which feed on the phloem of apple and pear trees, reducing nutrient uptake. They also excrete honeydew, which encourages the growth of sooty mold, and leave waxy excretions on fruit, which can be unsightly and pose a phytosanitary risk for export fruit. Mealybugs can be controlled using pesticides, but their waxy coatings and cryptic habitats can complicate chemical control. EPNs are nematodes of the families Heterorhabditidae and Steinernematidae. These are found within soil environments and are obligate parasites of insects, which they infect by entering through openings in the body and infecting them with symbiotic bacteria. EPNs are already sold as biological agents of soil-based biocontrol agents of soil-based insect pests, as they are highly lethal to insects while being otherwise benign to soil, humans, and the environment. Consequently, they have attracted interest as a means of pest control for insect pests on plant foliage, as opposed to just in soil. However, EPNs are ill-suited for above-ground environments, as they are susceptible to desiccation, extremes of temperature, and UV radiation. One means by which EPNs may be used as a biocontrol agent of Pseudococcus viburnii would be through the co-formulation of these EPNs with adjuvants. These are chemical additives that can be added to agrochemical solutions in order to alter their physical properties, either by decreasing the surface area that the sprays cover, by improving adhesion to plants, or by delaying the evaporation of chemicals, among others. In work by Platt 2018, adjuvants were shown to have potential in improving the activity of EPNs against the vine mealybug Planococcus ficus on grapevine foliage. Can we therefore apply the same logic to Pseudococcus obscurus in pome orchards? In our first year, our aims were to identify candidates for adjuvant additives to co-formulate with EPNs, to assess their compatibility with those adjuvants, and to assess how these adjuvants improve the ability of EPN species to seek out and infect Pseudococcus obscurus adults when not directly applied. This would be useful in controlling P. obscurus in cryptic habitats where direct spray application cannot reach. In our second year, our aims were to synthesize the above into an EPN and adjuvant treatment and to assess its ability to control naturally occurring infestations of Pseudococcus obscurus in pear orchards. However, the preliminary work for this trial, the year one work for this trial, was dependent on the maintenance of a viable P. obscurus colony. Samples were collected for such a colony in autumn of 2020 in conjunction with Stellenbosch University. However, COVID-19 lockdown meant that this was unavailable to maintain, and the travel ban made collection of new samples impossible. Continuation of this work must therefore be postponed until such a time as more samples can be collected and a new colony established. I'd like to acknowledge Experico Agri Research Solutions, Nomakolwa Stockway from Stellenbosch University, and Latour Di Matulwe. Thank you.